Hey guys, today we're going to be going through an introduction to data collection. So this is going to be a little bit of a change in pace. We're going to step away from programming for a moment and get into a little bit of how we handle data in computer science. All right, so let's go through this. So let's start with the first part. What is data? So you're not looking at always just numbers. You do have data in the forms of like words, symbols, and that kind of thing. So it can be numbers, but it's not going to be exclusively numbers. So what is data exactly? Well, data is the basis or building blocks for information. So far we've been talking most of the blocks when it comes to programming, but the same thing can be said for information. So types of data we're going to look at include quantities, such as numbers, characters, such as letters or grouping them together into words, or even symbols. Often the inputs and outputs of the computer programs. So there's normally some type of reason that you're using your computer, and oftentimes those are going to be data. So right now we are discussing informational data. So we'll discuss digital data later in the unit. So for the moment, we're just talking about informational data. All right, so how do you interact with data? Well, as you know, data is everywhere. Whether you're looking at your cell phone, you're looking at what's on TV, so much of it is based on data, even if it's just the story in a movie. So your name, address, height, and eye color is data. Your emails, your pictures, your text messages, these are also data. Any information that you interact with could also be considered data. So this could even be your basic communications, whether it be voice, text, image, all of this can be put in the form of data. So there's two major types of data that we're going to be talking about. So the two major groups is called qualitative and quantitative. So another name for qualitative is categorical data. So based on these names, what do you think these two types represent? So think of the terms qualitative and quantitative. All right, so let's first look at qualitative or categorical data. So this is the data that describes the quality or characteristics of something. This is going to be non-numerical in nature, meaning it is not represented by a number that holds a value. So again, this is going to be something that uses words, symbols, or imagery to describe it. All right, some examples of this could be hair color, your favorite food, the place you were born, name, your favorite shoe brand, or even your zip code. So again, we're basing something that is not specifically numerical. Like even though a zip code is numerical, it's defining a location. So that's really not, that would not be quantitative. A zip code would still be qualitative. All right, so answer the question here on the pop-up. What are some other examples of qualitative or categorical data? So again, it gave you some examples here. Name two things that are examples of qualitative data. All right, so now let's go into quantitative data. So this is data that shows a value or characterize something numerically, meaning that it's represented by a number. And the main thing here, like notice zip code was qualitative even though it was a number, but quantitative data can be counted and measured. That's really what makes it quantitative. Think quantitative would be like quantity. All right, some examples of quantitative data would be things like your age, shoe size, height, weight, GPA, the number of books on your bookshelf. I mean, again, anything that can be represented or counted numerically. All right, so as we did with qualitative, take a moment and come up with some other examples that could be quantitative. All right, so why do we need to differentiate between qualitative and quantitative data? Well, there are different ways we compare data, whether if it's a number or a descriptor. So we'll be talking about quantitative here and qualitative here because qualitative would be describing something. So numbers have value that can be directly compared to each other. For example, we know 8 is greater than 6 and -4 is less than -2. Words cannot be compared like that. So it's important we have to analyze these in different ways. So again, qualitative data and quantitative data are both important, but the way we compare them is often different. So back to the example of zip codes. These are numbers. So sometimes we have data that is represented by a number that is not quantitative. So like I said, zip codes are qualitative or categorical because it doesn't hold a numerical meaning. Just because the number is greater doesn't mean the location of a zip code is better. For instance, this zip code for Montgomery isn't greater than the zip code for the Birmingham, because these aren't comparing numbers as the numbers themselves. You could possibly say that Montgomery's real estate value is greater than that of the Birmingham zip code, but zip codes by themselves are not quantitative, they are qualitative. All right, so now let's go into how we collect data. So take your time here. So let's look at step 1. Step 1, you have to decide who you are collecting the data from. So one big question here, are you going to use a population or a sample? So 2 new vocab terms here. A population is a set of all the things being considered. And a sample is a small portion of the population or some of the things that are being considered. So the population would be everything, whereas a sample would just be a small portion of it. So think of like a subset. All right, so how do you know what to choose? So a couple questions you have to ask yourself. Do you have access to the entire group or the entire population? Second question, is it worth the time collecting data from the entire group? And is it worth the resources to collect data from the entire group? So next thing is, do you have a good sample? So a good sample is one that is representative of the entire population, and it gives each thing an equal chance of being chosen. So imagine you were looking at 100 people and each had a different viewpoint, but you could get a good sample by going and picking 10 of those people who all had similar beliefs based on the population and get a good sampling, as in you're getting a little bit of everybody's different viewpoints. So you wouldn't necessarily need to look at everyone in the population if you got a good sample and you got someone from each group. All right, so step 2, decide how you're going to collect the data. If you're going to collect from the entire population, you're going to be conducting a census. And this is kind of a term you don't hear very often, but every 10 years, the U.S. government has a census where we count everyone in the country, so we figure out how many people are living in certain areas. So your definition here, a census collects data from every member of a population, and if you are not collecting data from the population, you need to decide on what type of sample to conduct. So that takes us into our next part, the 3 different types of samples we'll look at. So these are going to be the 3 types of samples we're going to look at. You have a convenient sample, a voluntary response sample, and then a simple random sample. So let's look at each of these. So a convenient sample, this only includes subjects who are easy to reach. Some examples of this would be polling of your classmates or asking a business asking opinions from the people on a busy street. So again, you're not sending out mass mailers here. You're just literally talking to the people or reaching people that are convenient for you to reach. So if you're in school, your classmates would obviously be a great example of that. So there are some benefits to this type of sampling. So some benefits of convenient sampling. You're able to collect the data quickly. It's often very cheap, and it's easy to do research with this. And it's also easy to conduct. All right, so let's look at the next type of sampling, the voluntary response sample. So here, a voluntary response sample is made up of people who have chosen to include themselves here. Examples of this would be filling out a survey on the bottom of a receipt. So like if you go to Burger King or a restaurant or even a store and there's like a number to call, that would be a voluntary response sample. or you could be voting for your favorite contestant in a competition like American Idol. All right, some benefits to the voluntary response survey. These are very easy to collect, they're inexpensive, they require very little effort from the researcher, and they provide good specific information from an interested group. All right, so that's our second. Now let's look at our third and final that we're going to be looking at, which is the simple random sample. So here, a simple random sample takes data from a small random part of the population. Every member of the population has an equal chance of being chosen to participate. Examples of this would be things like a lottery or pulling a name out of a hat. All right, some benefits of the simple random sample. This is a fair method that helps reduce bias. There is no prior knowledge of the data that you're collecting. You need no technical knowledge of sampling, and there's no restriction on the sample size. All right, so we've talked about 3 different types of sampling. Now, which one would be best? Well, different types of samples are used for different purposes, so it really depends on the goal of the researcher. If you wouldn't want someone who has never been to a restaurant to rate your experience there. And also, you wouldn't want someone in California leaving input on the cleanliness of your school building, because more than likely there's some bias there. But sometimes with this type of sampling, it can introduce bias, which you don't want when you're talking about a whole population. So the only sampling methods that we've gone through so far that prevent bias is the simple random sampling. So when we've collected data, we always want to be aware of biases affecting our results. So biases are just things that could skew your results. So let's look at some data biases here. So data bias happens when the data does not accurately represent the full population being studied. This can be on purpose, or this could be on accident. So if it's on purpose, though, that's not good. That means someone's trying to fake something or hide something. All right, here's some examples of some data bias. So when you're trying to figure out whether the 10th grade class's favorite subject, and you're only asking people who are in your computer science class, and they all say computer science. All right, so because of this, you can come to the conclusion that the 10th grader's favorite subject is computer science. Well, you didn't sample from everyone here. So this would not be a very good representation of every 10th grader, because not everyone included in the sampling is representative of the whole population, because not everyone may be taking computer science. All right, so take a moment, and you may need to research this one, but have you ever seen any type of data bias in real life where someone tried to make the data tell its own story? So take a moment and answer that here.